Welcome to April 2nd's lesson. Hey, hope everyone is doing okay. And we're going to work on difference of two squares. Now, difference of two squares is just another type of factoring. It's taking a standard form expression and breaking it into two different pieces, right? Sometimes three, but we're really focusing on two this year. And by pieces, when I'm working with variables, I'm really talking about parentheses, right? So like x plus 1 would be a piece or a factor, right? And x plus 2 might be another factor. So we're talking about factors, those pieces, specifically in terms of the difference of two squares. So what does that mean? Yesterday's work, we talked a little bit about trinomials that were perfect squares. So remember, perfect squares are any square, right? So if this is a 5, this has to be a 5. If this side is an x plus 1, then this side has to also be an x plus 1, right? So they are perfect square trinomials if they are exactly the same in length and width. All right. So if I have an area model like this and I have x plus 1 and x plus 2, that's super close, but x plus 1 is a different length than x plus 2. So this would not be a perfect square. Okay. So with that in mind, I look at these three, right? Let me just name them 1, 2, and 3. And they're just telling me put a star beside any of these three that are in fact perfect square trinomials. So if I were to put them inside of a square or inside of an area model, it would give me identical lengths, right? Just like 5 and x plus 1 and x plus 1. All right. So think about it. Maybe pause me and see if you can figure out which one or ones are perfect square trinomials. While you do that, I'm going to erase this just so we have more room to work. Okay. So let's look at number 1. I have x squared plus 12x plus 36. So I'm going to set up my area model. Okay, and remember, this 12x kind of gets split between two boxes, right? So that would be split between here and here, right? So I know that those have to either add or subtract to give me 12, but I don't know exactly what they are. So I always start with x squared, which always goes in this first box, and the positive 36, which goes in this last box. And I didn't put plus because if there's no negative, we assume it's plus. All right, so now let me look at the factors. Remember, the factors are outside, the outside lengths. So if I need to get x squared, that is x times x. All right, so x times x gives me this x squared. Now, I'm not quite sure again about these two guys, right? So I'm going to focus in on the 36. Remember, I'm looking for a perfect square. Gotta be the same number. So, does 36 have any factors, right? Any of those outside numbers that could multiply to give me 36, right? So any factors that are the same. So let me just write them down here. I've got 1 times 36. That wouldn't do it. That wouldn't give me a square, right? The same. I've got 2 times 18. No. 3 times 12. 4 times 9, I think. 5 doesn't go into it. And then I've got 6 times 6. All right. That should make bells go off in your head, guys, right? So these are the same. And because they are the same factors, right, they can give me the same side lengths. So now I've got 6 times 6 is 36. Excellent. Now, let me fill in these other two boxes just to make sure it gives me that 12x. All right. So I'm looking at, let me get a different color. I'm looking at 6 times x, and that does give me 6x. And here I'm doing 6 times this top x, which gives me 6x. And 6x plus 6x gives me 12x. All right. So we got to make sure it matches that trinomial, right? That trinomial that's in standard form. And it does. And almost more importantly, it gives me identical sides, x plus 6 and x plus 6. Nothing can be different about these at all. They've got to be the same. So I'm going to put a huge big star there. And my factors, Miss Krim is always running out of room. My factors of, if I rewrite, x squared plus 12x plus 36, in factored form, that would be equivalent to x plus 6 times x plus 6, all right? And that could be written as x plus 6 squared, all right? So again, that perfect square, it can just be multiplied by itself. Okay, so now let's look at the other two. I'm just going to write those a little bit smaller. So here, again, I'm going to start with my first and my last term. So I say x squared goes first and negative 6 goes next. So x squared is a product of x times x. So far, I got a square. Now, negative 6, let me erase a little bit below it. Okay. All right, so negative 6 has factors of 1 times 6. And I'm not going to worry about the signs too much right now, right? I know one of them would have to be positive and one would have to be negative. 2 times 3, and then 3 times 2. And I know that as soon as I repeat, I'm done, right? So I found all my factors, but there's no pair that if I were to put like 2 and a 3 here, and I'd have to make like one of them negative to get that negative 6, there's no combination that would give me identical sides the way that I see over here with x plus 6 and then that same exact x plus 6 on the side. So this, nope. All right, and I'll let you guys do number 3 and figure that one out on your own. The only hint I'll give you is if I have 3x squared to start, that's got to be in the box, right? So I have x times x gives me x squared, but one of them has to be 3. So 3x times x gives me 3x squared. Now, could I get a square off of those starting factors? If I've got 3x and an x, think, are they the same? Are they identical? All right. So think about that, finish it up, and I will see you on the next page. Cool. All right. So today, what we're talking about is difference of two squares. This is super, like it looks really similar to perfect square trinomials, But where a perfect square trinomial has exactly the same sides, all right, difference of two squares will look identical, except that they will have two different signs. All right, and that's the only difference. So I make my area method box. I know that these two guys are factors, so they go outside 2x minus 1. And it doesn't matter if it's on the side or on top, right? Either one is fine. And then I'm going to multiply that by 2x plus 1, right? So I've got 2x minus 1 here, and I've got 2x plus 1 on top. All right, so now let's focus in on this first box. So I look up at 2x, I look to the side times 2x, and that gives me 4x squared. All right, hopefully you guys can see that square. Okay, all right, now I'm looking here. 1 times 2x gives me a positive 2x. Negative 1 times 2x gives me a negative 2x. And 1 times negative 1 gives me negative 1. All right, so to find the standard form, what I'm going to do is I'm going to write out all of the inside areas and combine any like terms. So I've got 4x squared plus 2x minus 2x minus 1. Okay, do you see where the like terms are? All right, so I see them right here, a positive 2x and a negative 2x. So 2x minus 2x gives me no x's. They cancel each other out. All right, so I would have 4x squared minus 1. Right, so 4x squared comes from here, minus 1 is here, and I don't have that middle term because 2 minus 2, it's 0, right? So 2x minus 2x, also 0. Okay, so I'm just going to write that here. 4x squared minus 1. And if you notice, 1 is a perfect square, right? Because I can have 1 times 1. And 4x squared is a perfect square because I can have 2x times 2x. Let me use a dot there so that it doesn't, I'll use a dot over here too, so that it doesn't look like an x. Sorry, guys. So, right. So if you notice, both 4x squared and 1 are perfect square terms. And I've got a difference here. And that's why it's called difference of two squares. So here I've got my difference. I'm going to run out of space, so I'll just put diff. Okay, so right here I've got my difference. And on the left I've got one perfect square term. And on the right I have my second perfect square term. Okay, so the difference of two perfect squares. All right, so the next one is written already in standard form. And just because there are two terms, that doesn't matter. It's still standard form. I've got my largest exponent written first with that 4. And then 100, it doesn't have any variables, so that's my constant. That goes last. And they want us to write it in factored form. All right, so just like the last one, see how I wrote these guys on the outside, right? Outside, right? The factors are outside of the box. In this example, I'm going to write this area inside the box. So let's do that over here. Okay, so my x to the fourth, that first term goes first. And in my last box, I don't just have 100, I have negative 100. Now, this is going to be a difference of squares. I don't have a middle term because something happens with these x's to cancel them out. Just like in the last slide where we had 2x minus 2x. All right, so x to the fourth. What is the same term that if I multiply it by itself gives me x to the fourth? And let me just do that to the side. So x squared times another x squared gives me x to the fourth. So I'm going to write those as the factors. Right? So x to the fourth is the area of this little box, and its factors are x squared and x squared. All right? And the fact that they're identical factors means that this x to the fourth term is a perfect square term. All right, now 100, right? If it's a negative, I know one of them has to be positive and one of the terms has to be negative. There's no other way to get a negative if you're multiplying. One's got to be positive, one's got to be negative. And again, we're looking for identical factors so that the middle two terms can cancel out. So think in your head, pause me if you have to. You should get 10 times negative 10. All right, so if you notice, this is not, the negative part is not the perfect square part, right? It's really 10 times 10, right? So the 100 is the perfect square, and the x to the fourth is the perfect square. Okay, the difference comes in the fact that I've got two different signs, right? And it's subtracting. So I've got, why did I write 10x there? Okay, so x squared times this negative 10 would give me a negative 10x. And here, x squared times a positive 10 would give me a positive 10x. All right. So just like in the last slide, if I have 10 minus 10, what does that give me? All right. You should have said 0. So $10 minus $10, $0. Same thing with 10x minus another 10x, 0 x's. So those cancel out. And I am left with x to the fourth, good, and negative 100, good. Now, let me write out my factored form. Again, that's the outside terms. So I'm going to have x squared minus 10 and x squared plus 10. All right, again, you can recognize dots, right? Difference of two squares in standard form because I have two perfect square factors, or sorry, wrong word. I have two perfect square terms with a difference in the middle. So the difference of perfect square x to the fourth and perfect square 100, all right? Or you can recognize it in factored form by having almost identical sides, except for those signs. There's a difference in the signs. Questions, concerns, you guys know what to do. So enjoy, email me, get your work done, but also balance it out with a little movement and laughter. I'll see you tomorrow.